Good morning, afternoon, or evening, ladies and gentlemen. How are you doing today? Welcome back to Mr. Morrell's Algebra I and II class. Today we're going to be talking about adding and subtracting rational expressions, but we're going to stay easy today. We're going to add and subtract rational expressions that already have a common denominator. Just as an aside, it just occurred to me, let's just remember real quick, we're going to go back in time. I know I'm not trying to dumb it down. I just want you to see the connections here, guys, okay? If I have 3/7 plus 2/7, remember, when we have the same denominator, you add or subtract the numerators and you keep the denominator. Done. If I had, whatever, 9/11 minus 3/11, that's going to be, I subtract the numerators because I have the same denominator, that's going to be 6/11, right? We'll talk about when they have different denominators. I'll give you the old school again so it could just resurface to your brain, and then I'll show you how it relates to today's, or to that day's lesson. So that's old school. We know that. How does this apply to what we're doing today? It's identical. It is identical. In order to add or subtract rational expressions with common denominators, simply add or subtract the numerators and keep the same common denominator. It's literally that easy, my friends. And then from there, we can actually simplify the rational expression as we've already learned before. Simplify the final rational expression to lowest terms. So there's not much to do here except for practice, 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 practice. So let's do it. 5 over x plus 1 plus 3 over x plus 1, they have common denominators. Literally, guys, that's 8 plus x plus 1. Done. You looked at me kind of crazy. What's going on? You got that? Okay, remember, you don't add these two together. You keep the same denominator because that's the common denominator. Again, just in case, if you're like, what did he just do? If I have 3/8 plus whatever, 3/8, that's going to be 6/8, and then we can reduce that to 3/4. But you add the denominator, the numerators, and you keep the same denominator. Number 2, I got x squared plus 7x over 7x plus 7. I wish I could say to you we're done, but we're not. We know better than that. We know how to simplify rational expressions. How can we simplify this rational expression here, my brothers? Absolutely, my brother. Factor out an x, and you got x plus 7 over x plus 7. Guess what? The x plus 7 cancels, and I'm left with x. Would I have any restrictions for this one? No, because remember, my brothers, you only have a restriction when there is a denominator of 0. So if I have a variable in the denominator, then I need a restriction. But in this case, the denominator is 1. I hope that makes sense to everybody. Here I've got 2x squared plus x over x squared minus 4 plus x minus x squared over x squared minus 4. Okay? You could factor the bottom and make it x plus 2x minus 2, but why? You've already got a common factor here, so let's see step by step how we would do this. This is going to be 2x squared minus an x squared, so that's x squared. And then x plus x is plus 2x over x squared minus 4. Now go ahead and simplify. Take out an x, so I got an x plus 2 over an x plus 2, x minus 2. The x plus 2's cancel. Am I allowed to take this x with this x? No. But I am allowed to rewrite this the right way, x over x minus 2, with a restriction that x cannot equal 2. Does everyone see this? We're going to do this all day today. It's just going to be with common factors. I just want you guys to get used to adding those numerators, simplifying those rational expressions. This is going to be a step-by-step process, I promise. Sir? I said don't factor it out yet. I said wait until you've added it. Now that you've added them together, now factor them out. I never said don't factor. I just said you can do it from the beginning, But sometimes I find that it's better to do it once you've combined everything. But that's a personal preference, my friend. Okay, here, be very careful with this one. Okay? Be very careful. Do I have common denominators? No. What can I do to this guy? Okay, now please pay attention. See how there's already a negative here? Okay, pay attention to what's going to happen here. This is a squared plus 2a over a minus 4. Now, this is going to be a negative up here, right, minus a squared plus 12, correct? You with me? Now, this negative, just so you know, has to get distributed to everything, okay? But before we do that, I'm going to factor out a negative from here, so I got a negative, now, a minus 4. What is a negative divided by a negative? So this becomes positive now. Did you see what I just did there, guys? Yes, sir. Yes. You don't distribute the negative because you don't have one anymore. That's why I like to wait until I see what I've done before I start distributing things. Okay? So now I have a squared plus a squared, which is 2a squared plus 2a plus 12 over a minus 4. Let's factor out a 2. So I got a plus a squared plus a plus 6 over a minus 4. Can I factor that out anymore? You can? What times what is positive 6? But when added together is positive 1. You cannot. So that's it. You're done. You guys with me? Okay. Real quick, though. I do want to show you something. Really? What times what is 6, but when added together is positive 1? It cannot, my brothers. Okay. Now, I do want to show you something. Let's just say that this was a minus 4. I want to show you what happens with this little negative here. I don't want you to get screwed up there, okay? This negative, this is subtracting this whole entire fraction. So that means that that negative must be distributed to here and here. So what this is really going to end up being is a squared plus 2a minus a squared minus 12 over a minus 4. And then here that would cancel. You'd get 2a minus 12 over a minus 4. Factor out a 2. So you'd have a minus 6 over a minus 4 with a restriction of a cannot equal 4. We don't care about the a in the numerator, only in the denominator. Did that make sense? This was a totally different problem, but I wanted to show you what happens with that negative. Sir?
So if you had to factor a negative in the denominator, then
you would bring up that negative to the top. If the top is already a negative, it's positive then. If it was a positive, then it'd become a negative. You with me? He said that when you go back, okay, right here. He said, okay, so when I pull out a negative from this, I got to bring it up to the top, and the answer is yes. That's why this negative divided by that negative became a positive. Thank you, son. Does that answer your question? Thank you. Yes, sir. If you brought up a 2, for example, which you wouldn't, but if you would, yes, you would have to distribute that as well. A 2 you would never bring up to the top. Because then if you brought up a 2 to the top, it would be 2 to the negative 1 power. You're only bringing up negatives, okay? Thanks, bro. Okay, for this one, easy peasy. Remember this negative, remember what I told you? Got to distribute it, so it's really 9x plus 1 minus 6x plus 2 over x plus 1. So this is going to be 3x plus 3 over x plus 1. Factor out a 3. So I got x plus 1 over x plus 1. So my answer is 3. No restrictions. Does that make sense, my friends? You promise? May I continue? All right. 10 plus 7 plus 3y minus 7. So that's going to be 3 plus 3y over 6y. I can factor out a 3 if I want to. Not if I want to. I can factor out a 3. And I got y plus 1 over 6y. Reduce it. Y plus 1 over 2y. What's my restriction here? Y cannot equal 0. That's my answer with my restriction. Does it make sense, guys? You promise? Okay. Here I got 2w minus 6 over... Oh, wait a second. I messed you up here. This is when it's different. So I messed up. Please change this 9 here, please, to a 16, please. Please change that 9, that's my bad, to a 16, please. So first off, do I have common denominator? No. What do I have to do to make it a common denominator? I can factor out a negative 1. But when I factor out a negative 1, what's going to happen to this negative here? So I'm going to have 2w plus 6 over w squared minus 16. I factor out a 2. I got w plus 3. I can factor this if I want. W plus 4, w minus 4. But in this case, it doesn't matter because I cannot cancel out anything. However, I do have a restriction that x cannot equal positive or negative 4. Remember the zero product property. Both of these factors must be set not equal to 0. Yes, sir. If it did not ask for the restrictions, you don't have to worry about it, sir. But I like to drill that into you guys so you can understand. And also, if they do ask, oh, that's right, Mr. Morrell's trained us for this. Thank you, sir. But a lot of times they're going to say, assume that all variables do not have any values that will make the rational expression undefined. They're usually going to say that. Assume that we're not using any of those. All right? Usually when they don't say that assume, it's when they want the restrictions. I will be clear about it. I promise. Thank you, son. Here, do I have common denominators? What do I got to do? I got to factor out a negative, but what's that going to make this positive now? So this is 3x minus 1 over x minus 5. Done. My restrictions, if I were asked, x cannot equal 5. Next, 2y. Yo, sorry, son. Yes, sir. Don't factor it to the end. Yes, sir. Yeah, yes. Thank you, my brother. This is going to be 6y plus 9. This is pretty much straight up. Oh, very good. Thank you for catching that. We do not have a common denominator yet. Thank you, my man. So I got to factor out a negative from here. What's that going to make this positive? A negative. So it's 2y minus 9 minus 4y. Please remember that has to be distributed over 6y minus 6. Great job, kid. So this is negative 2y minus 9 over 6y minus 6. I can factor out a negative. So I have 2y plus 9 over 6 times y minus 1. I can't reduce anything, so we're good. Yes, sir. 2y minus 4y is negative 2y. Thank you, son. Adding like terms. Yes, sir.
And the restrictions would be 1 and 2.
Thank you very much. No. For the restrictions, yes, you set x not equal to 0 and y minus 1 not equal to 0. But the only valid one here is y not equal to 1 because you know that 6 does not equal 0. There's no variable, so you don't have to worry about that. So that's my restriction. Thank you, son. Yes, sir. Because there was a negative here and a negative here, so I want a fully factored answer so I can see if I can start reducing. Because I can't cancel out any polynomials until I know that they are completely fully factored. Does that make sense? Thank you, my man. Okay, next. Artificial factoring, cubic method. So I'm going to go 3x, that's negative 3. What am I doing? What am I doing? Come on, Mr. Morrow. Common denominators. You just finished teaching this and now you're doing it wrong for the kids. Distribute the negative to everything. So 3x squared minus 2x squared is x squared. 8x minus 2x is 6x. And negative 1 plus 9 is 8. Excellent. Over x squared minus 3x minus 28. Now factor. Come on, Morrow. That was weak. Sorry about that, y'all. What times what is 8 but when added together is 6? Excellent. And what times what is negative 28 but when added together is negative 3? Perfect. X plus 4's cancel. So I got x plus 2 over x minus 7 where the restriction of x cannot equal 7. That makes sense. Promise? All right, good deal. I think, yes sir, we are done. All right, thank you very much. Hope you learned a lot. Have a great day.